Hi, this is Mr. Lee. This video focuses on dealing with questions that involve surds and indices. And there are two parts to the question. So let's get down to them. Okay, part 1, right? Here we are dealing with an equation involving 3 power of something times 2 power of something equals to 27 power of something and 2 power of something. Here your job is not to solve for x, but instead to evaluate the value of 6 power of x. Okay, the trick over here, right, is to actually recognize that the power x terms and the constants can be split up using your indices properties. Okay, so you notice that, for instance, there is a 2x and a minus 2. Okay, there is a x and a plus 1. Right, these constants should be separated out from the x terms in order for you to do your calculations properly. Okay, and just a quick revision of the properties of indices that we will make use of here over here. For instance, a power of m times a power of n, right? You add the exponents. A power of m divided by a power of n, you subtract the exponents. A power of -1, you take reciprocal. Okay, these are the 3 rules that you can apply to each of the terms over here in the equation. So for instance, the first term, the 3 power of 2x minus 2, you can express it as a fraction, 3 power of 2x divided by 3 power of 2. Okay, similarly, the 2 power of 2 negative 2x is just a reciprocal. Then 2 power of x plus 1 becomes 2x, 2 power of x times 2. So the next thing to do is to group all the terms with x, right? Separate them from the terms without x. Okay, and this is how you end up with terms over here. You do some cross multiplication, right, and division, so that all the x terms appear on the left hand side, the terms without x appear on the right hand side. Okay, and then you do another layer of your indices property, because here you're dividing exponents by exponents. You subtract the relative powers from each other. So 3 power of 3x minus 2x, 2 power of 2x minus x. Okay, and with that you get 3 power of x times 2 power of x equals to 2 over 9. And here you use one more property that says that so long as the exponents have the same power, same exponent, you can multiply the two bases together. And this actually gives you your 6 power of x. And that's your answer for part 1. For part 2, it's the same kind of idea. Right? Your job is to simplify this thing that seemingly has a lot of x terms. Okay, same trick. You first split the x terms away from those without. Okay, so here again we use the properties of indices. Okay, for instance, a power of x plus 2 is a power of x times x squared. Then with that, you see that you can also split the denominator. 2 power of a power of 2x plus 1 is a power of 2x times 8. Okay, so with that, you recognize that the surd is just a square root actually. Okay, and then you split the terms up this way. Okay, here again we are using some more properties of indices. Okay, and at the same time, one thing to observe over here is that 8 power of 2x to the power of half is the same as just a power of x. At the same time, for the numerator, you notice that both terms involve a power of x, which you can factorize out over here. And good news, right? Notice that the power x term actually cancels. And that basically simplifies nicely to our solution over here. 50 over square root 2 times square root 4, where you basically bring in the power half into both of the terms over here. And of course, square root 4 is 2. Okay, and that cancels out with the 50 to give you 20 over square root 2. Okay, just do a simple rationalizing, multiply throughout by a root 2 over root 2. You end up with the rationalized answer that you see on the right hand side over here. 25 root 2 over 2 is the final answer. Okay, that's for part A, right? We deal with primarily indices properties. Part B, right, on the other hand, deals with surds. So just do the usual expansion. Okay, 2 plus root 5 squared is just the usual a plus b squared. So do the a squared plus 2ab plus b squared. Whereas for your 36 over the 3 minus root 5, you notice that you have to rationalize. Multiply top and bottom by the conjugate of the denominator. Okay, that's a trick over here. And of course, if you simplify it nicely, right, you find that, well, you get a pretty neat number. In fact, this guy, 36, and denominator is actually 9 minus 5, which is 36 over 4. So this simplifies nicely to 9 times 3 plus root 5. Okay, do the expansion and eventually you get your answer over here. Okay, hope these questions weren't too bad, and we hope to see you in our next video.